Good afternoon, everyone. Today, I would like to talk about the 2011 Nobel Prize in Physics. I chose this topic because it reveals something surprising about the universe. The prize was awarded for the discovery that the expansion of the universe is accelerating. At first, scientists believed that the expansion of the universe would slow down over time. This idea made sense because gravity pulls matter together. However, observations showed the opposite. The universe is not slowing down. It is expanding faster and faster. This discovery was made by studying distant supernovae. These exploding stars act as standard candles that help measure distance. Scientists found that distant supernovae were farther away than expected. This means the expansion of the universe has been accelerating. To explain this, scientists proposed the existence of dark energy. Dark energy is a mysterious force that drives the acceleration. It makes up most of the energy in the universe. This discovery was very important. It changed our understanding of the universe. It showed that unknown forces can dominate large systems. I find this discovery very fascinating. It shows that the universe behaves in unexpected ways. It also teaches us that our assumptions can be wrong. In the future, scientists hope to better understand dark energy. Even though this topic may seem abstract, it gives us an important message. Systems can evolve in ways we do not expect. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2011 Nobel Prize in Chemistry. I chose this topic because it changed the way scientists think about order in solid matter. The prize was awarded for the discovery of quasicrystals. At first, this may sound unusual, but it is a very important discovery. For a long time, scientists believed that crystals had to have a repeating atomic pattern. In other words, the structure of a crystal was expected to repeat regularly in space. This idea had been accepted as a basic rule in chemistry and materials science. However, quasicrystals did not fit that rule. They showed a new kind of order. Their atomic arrangement was highly organized, but it did not repeat periodically like an ordinary crystal. This was already surprising, but there was an even more remarkable point. Quasicrystals also showed symmetries that had long been considered impossible in normal crystals. These are sometimes called forbidden symmetries. For example, patterns with five-fold symmetry were thought to be incompatible with true crystal structures. According to the traditional view, such symmetry could not fill space in a regular repeating way. However, quasicrystals proved that solid matter could have order without periodic repetition and still display these unexpected symmetries. At first, many scientists doubted this discovery. It seemed to contradict the established definition of a crystal. However, further experiments confirmed that quasicrystals were real. This discovery was very important. It forced scientists to revise their understanding of crystal structure and solid matter. It showed that nature can create order in ways that go beyond older theoretical limits. I find this discovery very fascinating. It shows that scientific rules are sometimes too narrow to describe the full richness of nature. It also teaches us that when new evidence appears, even basic definitions may need to change. In the future, quasicrystals may help scientists develop new materials with unusual and useful properties. Even though this topic may seem abstract, it gives us an important message. Nature can produce patterns that are both orderly and surprising at the same time. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2011 Nobel Prize in Physiology or Medicine. I chose this topic because it shows how the immune system not only fights disease, but also knows when to begin fighting. The prize was awarded for discoveries concerning the activation of innate immunity and for the discovery of the dendritic cell and its role in adaptive immunity. At first, this may sound complicated, but the basic idea is very important. The immune system has two main levels of defense. The first is innate immunity, which provides a rapid and immediate response to danger. The second is adaptive immunity, which produces a more specific and targeted response. For a long time, scientists did not fully understand how the immune system detects danger and starts its defense. One major discovery showed that innate immunity is activated when immune cells recognize characteristic molecules from bacteria and other harmful microbes. In other words, the body has a built-in system for detecting invasion at a very early stage. This early recognition is essential because the immune response must begin before an infection spreads. Another major discovery involved dendritic cells. These cells play a key role in connecting innate immunity with adaptive immunity. After detecting and processing foreign substances, dendritic cells present this information to other immune cells. As a result, the body can launch a more specific and effective defense. In this way, dendritic cells do not simply detect danger, they help the immune system decide how to respond. This discovery was extremely important. It showed that the immune system is not just a passive shield. It is an active and highly organized system that detects threats, starts early defense, and then builds a more specialized response. This knowledge has had a major impact on medicine. It has helped scientists improve vaccines, understand inflammatory diseases, and develop new forms of immunotherapy. I find this discovery very fascinating. It shows that survival depends not only on strength, but also on recognition and communication. It also teaches us that an effective defense system must know when to act and how to pass information to the right partners. In the future, this knowledge may help us create better treatments for infections, cancer, and immune disorders. Even though this topic may seem technical, it gives us an important message. To defend life effectively, the body must recognize danger quickly and respond in a coordinated way. Thank you.